In the previous video, we covered modes of heat transfer. We took a look at heat conduction. And in passing, we also covered heat convection. Let's now move on to the third mode of heat transfer, heat radiation. Aside from the heat transfer mechanisms of heat conduction and heat convection, we have heat radiation or thermal radiation. Heat radiation is heat transfer via the emission and absorption of electromagnetic waves. When we say electromagnetic waves, we're basically talking about light and the different types or spectra of light. For heat radiation, we're typically talking about infrared light and visible light. So heat radiation is heat transfer via the emission and absorption of infrared light and visible light for the most part. An object will emit thermal radiation as long as it has temperature greater than absolute zero, which means as long as the temperature of the object is non-zero Kelvin or greater than 0 Kelvin, the object will emit thermal radiation. And the rate at which an object will emit thermal radiation is given by H average is equal to sigma AET to the fourth power. Again, that's average heat transfer rate. H average is equal to sigma AET to the fourth power. Sigma is a constant, the Stefan-Boltzmann constant. It's equal to 5.6704 times 10 to the negative 8 watts per meter squared Kelvin to the fourth power. And area A is area of the emitting surface. The whole object might be emitting thermal radiation. A is equal to total surface area of the object. But it's also possible that only part of the object is emitting thermal radiation. A is the area of that part of the object that is emitting radiation. So A is area of the emitting surface. E is emissivity of the surface that is emitting. Emissivity E is a unitless quantity ranging from 0 to 1. If E is equal to 1, the object or surface is referred to as a black body. A black body is an ideal emitter and absorber of heat energy, of heat radiation. So it doesn't matter what wavelength of infrared light or what wavelength of visible light that is being emitted or absorbed, it doesn't matter. As long as it is infrared light or visible light, the object will either emit or absorb the thermal radiation. And if E is equal to 0, we have an ideal reflector of heat. The radiation will simply bounce off the surface. And if E is equal to 0, the amount emitted by the amount of thermal radiation emitted by the object will be equal to 0. The object is not emitting any radiation, and any radiation that is incident on the surface of the object will simply bounce off. ideal reflector of heat. And T is temperature in Kelvin. So note, it must be in the Kelvin scale. T is temperature of the object in Kelvin scale. And don't forget that T is to the fourth power. So H average is equal to sigma AE T to the fourth power, the rate at which an object will emit thermal radiation. And as long as T is non-zero, as long as T is greater than 0 Kelvin, the object will have H average, the object will emit thermal radiation. While an object is emitting thermal radiation, at the same time, it is also absorbing thermal radiation from its environment. So there are two heat transfer rates associated with the object, H emit and H absorb. The total heat transfer rate of the object, H total, is given by H absorb minus H emit. We put a minus sign with H emit because technically speaking, H absorb is heat gain and H emit is heat loss. And by convention, heat loss is negative. So we put a minus sign with H emit. H total is equal to H absorb minus H emit. And H emit, we covered in the previous slide. H average is equal to sigma AET to the fourth power. So H emit is AE sigma T to the fourth power. Sigma is still the Stefan-Boltzmann constant. E is still the emissivity of the surface of the object. A emit, area of the emitting surface. Whatever part of the object is emitting, the surface area of that part, that's A emit. And T is temperature of the object in Kelvin. And don't forget the fourth power. So sigma A emit E T object to the fourth power. We use this equation also for H absorb with some changes. H absorb is equal to sigma A absorb E T environment to the fourth power. Instead of area of the emitting surface, now A is area of the absorbing surface. Whatever part of the object is absorbing the thermal radiation coming from the environment, that's A absorb. And T, of course, is temperature of the environment from which H absorb came from. And again, don't forget to the fourth power. So H total is equal to H absorb minus H emit is equal to sigma A absorb E T environment to the fourth power minus sigma A emit E T object to the fourth power. If H total is positive, that means the overall behavior of the object is absorbing heat radiation. But if H total is negative, meaning H emit is greater than H absorb, H total is negative, that means the overall behavior of the object is emitting thermal radiation. And that's it for now. That's it for our discussion on heat radiation. We'll continue our discussion on temperature and heat in the next video. We'll finish the topic of temperature and heat in the next video with a few more examples. So again, that's it for now, and thank you for watching.